Okay, this video accompanies the 5-4 reveal mathematical literacy and vocabulary, mainly focused on congruence and right triangles and introduction to setting proofs up. So let's see what we have here. Let's see, here's the problem. So they want us to prove that AB is congruent to CD. So let's look at AB and CD, or ED rather. So here's AB. And here's ED. They want us to prove that these two segments are congruent to each other. So generally what we need to do is, if these are going to be congruent, we need to find the triangles that they're the corresponding parts of. So we can see that triangle ABC and triangle EDC are two triangles that if we prove them congruent, DE and AB or BA would be corresponding parts of those triangles and would have to be congruent also. So that's the way this proof needs to go. Now we can see we have right triangles, so that opens up hypotenuse leg as a possibility, or maybe side angle side, depending on what else we're given. And also they tell us that C is the midpoint of AE. So if C is the midpoint of AE, that means that the two hypotenuses are congruent to each other. And if C is the midpoint also of BD, that means that these two legs are congruent. So I can see that, or we should be able to see that, a hypotenuse leg is a pattern that we can use to prove that these are congruent to each other. And then once we have these two triangles proved congruent, then by corresponding parts, AB is going to be equal to ED. Which means they're going to be congruent. So that's how this proof is going to need to go. Okay, so let's go and answer the questions here. So what's the definition of the midpoint of a line segment? Okay, a midpoint divides divides a segment into two congruent parts. I'm going to use congruent sign. Cuts it in half. So that's what a midpoint of a line segment does. Let's look at the next part. Using the given that C is the midpoint of AE and BD, with AB being parallel to DE, and the measure of B is 90 degrees, these are all the things that were given. Now, they didn't list that these were 90 degrees, but we can see that they're marked as 90 degrees. That's how we were given it by way of the diagram. The markings here on A, B, and DE are telling us that these segments are parallel to each other, and then we're also given that C is the midpoint of AE. So out of all the given information that's listed, the midpoint is listed. The other parts we need to draw from the way the diagram is marked. So that's an important thing you need to think about when you're looking for the given information that you can use. Okay, so how do you know that AB is parallel to DE and the measure of angle B is 90 is the question. Well, AB and DE are marked in the diagram as being parallel. That's one part. How do we know that the measure of B is 90? Well, so D and B are right angles and equal 90 degrees. That's what we can use for that one. Okay, let's look at the next part here. AC is congruent to EC, and BC is congruent to DC using the definition of midpoint. What does a symbol congruent mean between two segments? It means they're congruent. The segments are congruent. They have equal measures. Okay, let's look at number 3. They're saying that angle B is congruent to angle D. Well, they are. We don't really need that for the proof because we're told that they're right angles, but also we can see that they're alternate interior angles and they have to be congruent. If one's 90, the other has to be 90. The other thing, working backwards, if we didn't know that these lines are parallel, just the fact that these are alternate interior angles that both have the same measure, by the converse, we would know that those lines are parallel. So for this same proof, they could have instead asked us to prove that AB is parallel to DE and not given us that information about the lines being parallel to begin with. And then we could have found that by alternate interior angles being congruent, lines must be parallel. But let's see what they're doing on this one. So for this, they're asking, so B and D are alternate interior angles. Remember, alternate interior angles, you kind of do like a Z, and the inside parts of the Z, whether you're going this way with the Z or that way with the Z, these inside parts are the alternate interior angles. And if you have parallel lines cut by transversal, alternate interior angles are going to be congruent. Alternate sides of the transversal line inside the lines that are crossed. So interior means between the parallel lines. Okay, let's look at the next one. Angle B and angle D are right angles. The definition of a right angle, we know they're right angles. What's the measure of angle D? 90 degrees, because right angles measure 90 degrees. Let's look at number 6. So they're saying, or we're able to say that triangle ABC is congruent to triangle EDC using hypotenuse leg. What information is necessary for hypotenuse leg? Well, if we look back up here at the diagram, for hypotenuse leg, we need to show that the two hypotenuses match up, which is what we get from C being the midpoint of this side here. And we need to show that the two legs are congruent, which is what we get from C also being the midpoint of this here. And because these are right triangles, we can use hypotenuse leg. So what information is necessary to apply the hypotenuse leg theorem? Okay, triangles must be right. Doesn't work with other triangles, only with right triangles. Also, hypotenuses need to be congruent. I spelled hypotenuse wrong. So hypotenuses must be congruent, and one leg set must be congruent. So let's say we had these two right triangles like this. They're right triangles. The hypotenuses have to be congruent, and at least one leg needs to be congruent. That gives us the hypotenuse leg. Okay, let's see what's else. Now AB is congruent to ED by corresponding parts of congruent triangles. What are the corresponding angles and sides for these two triangles? So if triangle ABC is congruent to EDC, let me make sure they have that named in the right order. ABC, ABC, EDC. So ABC and EDC. Yeah, so these two triangles are congruent. So triangle ABC is congruent to triangle EDC by HL, by hypotenuse leg. And now we can use the congruence statement to kind of match things up. Angle A is congruent to angle E. Angle B is congruent to D. And angle C is congruent to C. That's actually, we could have done that with reflexive property also. In terms of, that's in angles. In terms of the sides, side AB is congruent to side ED. Side AC is congruent to side EC. And side BC is congruent to side DC. So these are the 6 pieces of the two triangles that are congruent. So notice on this one, all it really took was showing that with the right triangles that you had 2 parts that were congruent, a set of legs and a set of hypotenuses, and that was enough to force the triangles to be congruent, which means all 6 pieces of the triangle are congruent.